There are a number of factors that can affect the solubility of a material, and a lot of those factors, most of them in fact, are based on the application of Le Chatelier's principle. The first factor that we'll talk about is temperature. A change in temperature is going to cause a change in the KSP for the solubility equilibrium that you're looking at. And typically, an increase in temperature is going to correspond with an increase in the KSP. And an increase in the KSP corresponds to an increase in the solubility of that solid. That is, more of the solid will dissolve and split up into ions. The second factor that we'll talk about is the common ion effect, where the presence of a common ion is going to shift the equilibrium to the solid side. So a common ion that shifts the equilibrium to the solid side means that more of that material is not dissolving, more of it is staying precipitated, which corresponds with a decreased solubility. The next factor that we'll talk about is the pH. And in general, a change in pH is going to affect ion concentrations. So an example of this would be something like the dissociation of the weak base, magnesium hydroxide. This equilibrium, this solubility, is going to be pH dependent. If you add a strong electrolyte source of hydroxide ions, say you add sodium hydroxide or something, you're going to be adding a lot of OH- ions, which is going to drive this equilibrium to the solid side, and it's going to decrease the solubility. So this is essentially just the common ion effect all over again. But you can also add an acid. And if you add an acid, it's going to react with the hydroxide ions to make water. And if you do that, you're going to be reducing the equilibrium concentration of the hydroxide ion, which means you're going to be affecting the Q value, the reaction quotient. You'll be removing hydroxide ions, and more of the magnesium hydroxide is going to have to dissolve to replace them. So you'll be increasing the solubility of this material when you add acid or when you lower the pH. The final factor affecting solubility that we're going to be talking about is the presence or formation of a complex ion. So a complex ion is just a structure or some material made from a metal ion that reacts with a Lewis base. So a common example would be silver ions and ammonia. This is technically an equilibrium reaction, but the K values for the formation of these complex ions is enormous. So the value for the Kf, the K formation for this complex ion, is 1.7 times 10 to the 7. It's an enormous value, and it means that if you have silver ions and ammonia present with one another, they're almost entirely going to react to form this silver diamine complex. And because this K value is so huge, it means any free metal ions that are going to be present will immediately react with that Lewis base, if there are any Lewis bases around to react with. So if you have a silver chloride solubility, for example, silver chloride solid dissociating to give you silver ions and chloride ions, once you're at equilibrium, you're going to have a certain amount of solubility, a certain amount of silver chloride will dissolve. But if you add any ammonia at all, it's going to react with the silver ions. And that means all of the silver ions will be removed, and they'll be converted almost entirely into that silver diamine complex ion. And because the silver ions have been removed, more silver chloride will have to dissociate in order to replace them.